Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah, and now today we are going to discuss what is mirror equation. In other words, what is spherical mirror formula. Okay, let me recall the previous work what we have done yesterday. If you remember, in the previous lecture we have discussed we have discussed how image formation was from concave mirror, from convex mirror, what was the ray tracing, and all those things we have discussed. In concave mirror, ray tracing we have done, we have discussed image formation, we have discussed 5 cases of it. Last case was very special case, if you remember. Okay, in convex mirrors we have discussed the ray tracing as well, we have discussed image formation as well, and there was only one case of image formation through a convex mirror. This was all about previous work. Let me discuss today's work. Today is lecture number 4 of class 10th physics, chapter number 12. In other words, chapter number 3, that is geometrical optics. Okay, now we are going to start with mirror equation. In other words, spherical mirror formula. Okay, first of all we need to understand what is spherical mirror formula or what is spherical mirror equation. Now look, spherical mirror formula or mirror equation is a relation between 3 quantities: di, image distance; d naught, object distance; and focal length of the mirror. If we relate these 3 quantities, this will give you spherical mirror formula, or in other words, equation. So we can say that the relation between di, d naught, f is known as mirror equation. Okay, so how can we define it? The expression or the relation which is between 3 quantities di, d naught and f. These 3 quantities relation will be termed as what? This will be termed as mirror equation, or we can say that mirror's formula. Okay, so the formula which gives the relationship between image distance, object distance and focal length of the mirror is known as what? Mirror equation or mirror formula. Mathematically we can write that 1 over f is equal to 1 over di plus 1 over d naught. 1 over f is equal to 1 over di plus 1 over d naught. Okay, to explain this further, let me draw a diagram. If you remember, when we were discussing image formation by concave mirror, the third case of image formation through a concave mirror we have discussed in the previous lecture. The same diagram I have drawn over here. This is the same diagram we have taken from there. Now what is happening over here in this diagram? In this diagram we have placed an object between center of curvature C and focal length f. We have placed an object between center of curvature C and focal length principal focus f. Object is placed between C and principal focus f. We have placed an object AB over here. The height of the object, say it is h naught. Okay, now what is happening over here? In this case the 2 rays are coming. The first ray is coming like this and striking the pole and reflecting over here by this way. Okay, second ray is coming like this and it first passes through principal focus, then strikes the mirror at point E, and after reflection, according to the rules, it becomes very parallel to the principal axis. These 2 rays are coming and striking the mirror and following their own path as discussed in the rules. Okay, and they are intersecting with each other at this point, and the image is forming over here. I have shown this image by A dash B dash. This image is inverted because arrow is downward. We are using concave mirror, that is why image will be inverted. We have discussed in the previous lecture. Okay, now we can say that this height of image, like this is image and it has some certain height. Say this is height of image, say hi. Okay, now this distance, object to mirror distance, let me call it d naught or di. this distance, object to mirror distance, let me call it D naught. This is object, this is mirror, the distance in between let me call D naught, in other words D naught or object distance. Okay, this is what? This is image. A dash B dash is what? Image. The distance between mirror and image let me call DI. Okay, the distance between principal focus and pole we call it focal length. Let me represent it by small f. Okay, then we are comparing. Now let's come towards the derivation for this mirror equation. Okay, let me discuss in different steps. The first step, we have to compare two triangles. We have to compare two triangles, triangle ABP and triangle A dash B dash P. We are comparing these two triangles. In mathematics, we have a rule that the ratio of equivalent sides of a similar triangle are equal. The ratio of equivalent sides of similar triangle are equal. Okay, let's come to the diagram again. Okay, if you see in this diagram, I have shown these two triangles by blue shade. Let's come towards this diagram again. Look, in this diagram I am talking about which two triangles? I am talking about this A dash B dash, sorry, A B P, this triangle, and A dash B dash P. I am comparing these two triangles. Okay, I am taking a ratio of perpendicular to perpendicular and base to base. I am taking these two ratios. Look, in the first triangle, what is perpendicular over here? AB is perpendicular over here. I have written AB over here. Okay, in the second triangle, what is perpendicular? A dash B dash is perpendicular. I have written A dash B dash over here. Okay, now base to base ratio we are going to take. Look, in the first triangle, which is base? BP. In the first triangle, BP is the base. So let me write BP over here. In the second triangle, what is base? B dash P is base. In the second triangle, B dash P is base. Let me write B dash P over here. Okay. Now, what is AB? AB is actually height of object. What is A dash B dash? It is height of image. I will write minus just to show that image is inverted. Okay. What is BP? Look, B to P distance is represented by D naught. Let me write what is BP, that is D naught. So I have written D naught over here instead of what? BP. Now what is B dash P? Look, this is B dash and this is P, and the distance between B dash P is represented by DIOR, image distance. So let me represent it by DI. So I have replaced these two values over here. Done ho gaya? This is what? This is equation number 1. Now again come now we are comparing further two triangles. Coming back to the same diagram once again, this time we will consider green shaded triangle. Now look, I am talking about which triangle? I am talking about this green shaded triangle ABF and this green shaded triangle FPE. I am comparing these two triangles, comparing triangle ABP and FPE. Okay, the same rule we will use, the same ratio we will use. Look, what is rule? The ratio of equivalent sides of a similar triangle are what? Equal. Okay, now the same rule, perpendicular to perpendicular and base to base ratio we are going to use. Look, in the first triangle, what is perpendicular? AB is perpendicular in the first triangle. Let me write AB over here. In the second triangle, what is perpendicular over here? PE is perpendicular over here. Let me write PE over here. in the first triangle, what is base? Look, in the first triangle, BF is base. Let me write BF over here. Now, in the second triangle, what is base? FP is base. Let me write it over here. Now look, what happened? What is the value of AB? AB is actually H naught. Let me represent it by H naught. What is PE? PE is actually HI over here. Let me write HI. Actually, I have drawn in diagram a slight curve. Actually, in real sense, if you see, the mirrors are not this much curved. Just to show you, I have drawn like this, okay? Minus sign show you this is actually like perpendicular, okay, like it's very near to it, not that much curve but very near to straight or perpendicular. Minus sign shows you what? Minus sign shows you that image is inverted. Now coming towards the right side, look, what is FP? The distance from principal focus to pole, and we know that that distance is what? That is focal length. Now come towards what is BF? BF distance. What is BF distance? Look, this is BF distance. Now how we will find BF value? Look, I can say that BF is equal to BP minus FP. The BF distance can be found if I subtract BP. If we have a total distance BP, we have a total distance which B to P, and if I subtract FP, this distance, what I am going to get? BF I am going to get. Do remember one thing, if I subtract FP value from BP value, I am going to get BF. Again, this is very tricky, please understand. Please understand, this is very tricky. To get BF, what we do? If I subtract FP value from BP value, what I will get? BF. Okay, so BF is equal to BP minus FP. BP value is D naught, FP value is small f. Okay, BF value is this D naught minus F. Let me write instead of this BF, D naught minus F. Okay, now what we do, this is equation number 2. Now let me call this equation as equation number 2. Now let's come towards step number 3. In step 1 we have got this equation, in step 2 we have got this equation. If you see, equation 1 left side and equation 2 left sides are equal, so automatically by we can say that their right and right sides will be also equal. This is transitive property. Okay, now comparing equation 1 and 2, we are going to get, okay, D naught divided by Di is equal to D naught minus F divided by F. Okay, D naught divided by Di is equal to D naught minus F divided by F. So I have written this same equation over here. Done ho gaya? Left side and left sides are equal, automatically their right and right side will be also equal. Okay, now what we do by cross multiplication, we are doing cross multiplication, like multiply these two terms. Okay, by cross multiplication what we are going to get? We are going to get multiply D naught by F like this, D naught F, and this Di with D naught minus F. Okay, Di into D naught minus F, multiply it, Di D naught minus Di F मिल जाएगा आपको. ठीक हो गया? यहाँ तक क्लियर है? डन है? कोई मसला नहीं? Okay, now look, let's come towards step 4, dividing D naught, Di and F throughout the equation. We are going to divide D naught, Di and F throughout the equation. When you multiply, when you divide throughout the equation, like this is the equation, okay, DIF is equal to Di D naught minus DIF. This equation will be divided throughout. Throughout means on each term. Throughout means on each term divide what? Di D naught F. D naught DIF, D naught DIF, D naught DIF. This is divided throughout. Look over here, D naught will be finished. Small f will be finished. Over here, D naught will be finished with D naught Di, and over here DIF will be finished with DIF. Okay, what we are going to get? What we are going to get is 1 over Di is equal to 1 over F minus 1 over D naught. Let me shift 1 over D naught on the right side, if I shift, so I will get 1 over di plus 1 over d naught is equal to 1 over f, or we can also write that 1 over f is equal to 1 over di plus 1 over d naught, which is spherical mirror equation, or the mirror equation. In other words, we can say spherical mirror formula. So this was all about today's lecture. Hope you have enjoyed it, right? Let me summarize today's work. In today's work, we have discussed what is mirror equation or spherical mirror formula. We have discussed that spherical mirror formula or mirror equation is a relation between three quantities di, d naught, f. The relationship between di, d naught, f, known as spherical mirror formula. Mathematically, we can write that 1 over f is equal to 1 over di plus 1 over d naught. Now the diagram we have considered, if you remember, this is very well known diagram. This is not something new diagram. This is very well known diagram. We have done this diagram. We have discussed this diagram when we were discussing concave mirror image formation. Image formation by concave mirror, case number 3. Third case. This is the same diagram I have drawn over here, very well known diagram. In the previous lecture, we have also discussed this diagram. Okay, we have placed an object between center of curvature C and principal focus F. Okay, according to the rules, the first ray comes and strikes at pole and moves over here as shown. Secondly, second ray comes, passes through principal focus. According to the rules, first passes through principal focus, then strikes the mirror at point E and become very parallel to the principal axis. Done ho gaya? Now, what I do, like I show what is D naught, what is F, what is DI. Okay, this was a thing. Now, I have shaded two triangles. Look, blue shaded triangles. This one, A, B, P. This is first blue shaded triangle, A dash, B dash, P. This is second blue shaded triangle. We are comparing these two triangles. Let's come towards derivation. Okay, in derivation we say triangle ABP and triangle A dash, B dash, P. We are going to compare these two triangles. Now the rule upon which we are comparing these two triangles are the ratio of equivalent sides of a similar triangle are equal. So we can take a ratio of perpendicular to perpendicular, base to base. In the first triangle, okay, in the first triangle we have discussed perpendicular to perpendicular, base to base. Similarly, now perpendicular to perpendicular in the first triangle, triangle ABP, A dash, B dash, P. What is perpendicular? AB in the first triangle, I have written AB. What is perpendicular of the second triangle? A dash, B dash, I have written A dash, B dash. Okay, now come to base. What is the base in the first triangle? BP. Let me write BP. What is the base in the second triangle? B dash P. Let me write B dash P. Okay, now just replace the values H naught divided by minus HI, D naught divided by DI, minus because we have inverted image, that is why. Okay, now comparing green shaded triangle, come back to the same diagram. Triangle ABP, triangle FPE, where is it? I'm talking about this triangle ABF, ABF and FPE. Sorry, this is ABF. ABF. Okay, what is perpendicular? AB, I have written AB. What is perpendicular of the second triangle? PE, I have written PE. Done ho gaya? Okay, what is height of the first? This is replaced value. AB will be replaced by H naught and PE will be replaced by minus H naught, minus because image is inverted. On the right side, FP, the distance from principal focus to pole is represented by focal length. I have written small f. Now come, this is very tricky. What is BF value? If I subtract FP value from BP value, I am going to get BF value. BF is equal to BP minus FP. BP is what? D naught. FP is what? FP is what? Small f, mean focal length. So just replace the values over here by cross multiplication. We got this result and come to step 4. In step 4 we have divided D naught DIF throughout the equation. Throughout mean on each term we have divided it. We have got 1 over DI is equal to 1 over f minus 1 over D naught. Okay. we are shifting this d 1 over d naught or on the right side, so 1 over di is equal to 1 over di plus 1 over d naught is equal to 1 over f, or in other words we can say that 1 over f is equal to 1 over di plus 1 over d naught, which is required mirror equation or spherical mirror formula. This was all about today's lecture, one of the most important topic. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz, fi aman Allah.